Hi Geometry, this is notes number 3 for Unit 2. Our learning targets for these notes are, well, we have a bunch of them. I can classify triangles by their sides and angles. I can apply the triangle inequality theorem, and I can apply the triangle angle sum theorem. So the triangle inequality theorem and the triangle angle sum theorem are the two that we explored in our discovery activity. So these should be a little bit familiar. So we discovered in that activity that our triangle inequality theorem says the sum of any two sides of a triangle must be greater than the third side. So if we look at this theorem in action, can the side lengths 5, 6, 9 form a triangle? So we need to check that when we add any two sides together, that answer must be greater than the third side. So 5 plus 6, that's 11, that's greater than 9. Next we'll check 6 plus 9, that's 15, that's greater than 5. 5 plus 9 is 14, that's greater than 6. So if the answer to all three statements is greater than, then a triangle can be formed. So yes, 5, 6, and 9 can form a triangle. But there's also a shortcut. Really the only two sides that we need to check are just the two shortest sides. So if our two shorter sides add together and are greater than the third side, then our triangle is going to be formed. So I really just needed to check for this one. Is 5 plus 6 greater than 9? That is absolutely true. So I can say yes, that makes a triangle. So in these try it problems, I am going to use the shortcut. So I'm going to look for my two shortest sides, and when I add them together, they need to be greater than the third side. Not greater than or equal to, they need to be greater than. So if I look at number 1, well, all three of these sides are the same. So if I look at, here's my short side, oh look, they're all short sides this time. So if I add my two short sides together, 9 plus 9 is greater than 9. That's absolutely true. So yes, I can make a triangle here. I'm going to skip down to this should be number 4. Number 4 right beneath it. So if I add my two shorter sides together, 7.2 plus 12.3, is that greater than 24.1? Well, this ended up being 0.5. 19.5 is less than 24.1. So no, those side lengths cannot form a triangle. So pause the video, try the other 4 problems, see which ones can form a triangle and which ones cannot. All right, check your answers on those 4. If you have questions or you're not sure why you got something wrong, definitely send us a message and ask. We can explain anything. Come see us during office hours, all that stuff. All right, so triangle angle sum theorem was the other theorem that we discovered in our discovery activity. So we learned that the sum of the interior angles, so meaning the angles on the inside, the sum of the interior angles in a triangle is 180 degrees. So anytime I have a triangle, if I add all 3 angles together, it should be 180. So in this first try it problem, I'm asked to solve for x. So I have 3 angles here. So I'm going to create an equation that says 2x plus x plus 4 plus x plus 16 is 180. I need all 3 of those to add together to equal 180 degrees. So I'll combine my like terms. Got a bunch of x's in here. So 2x plus x, that's 4x. Combine my constants. 4 and 16 is 20. So 4x plus 20 equals 180. So 4x is 160. X has to be 40. In number 2, they ask you to find angle ABC. So not only do you need to solve for x, you then need to plug that value in, substitute it so that you can find the measurement of angle ABC. Pause the video, try the next one, and then come back and check your answers. Okay, for this one, your equation, we add all 3 angles together, it should equal 180. Don't forget, this little box in the corner tells us that this angle is 90 degrees. So when I solve that equation, we get x equals 9. To find the measure of angle ABC, I outlined ABC in my diagram. So that's the angle that has a vertex at B. The expression that represents that angle is 5x plus 7. So when I substitute 9 in, we get that the measurement of that angle is 52 degrees. So that's the summary of what we did in our discovery activities. But our other learning target talked about classifying triangles. So now that we know some more information about triangles, we can start classifying them. So triangles are classified by their angles and by their sides. So when we name a triangle, it gets 2 names. It gets a name based on its angle measurements, and it gets a name based on its side lengths. So an acute triangle, all of your angles are less than 90. A right triangle, you have one 90-degree angle. An obtuse triangle, you have one angle that's greater than 90. When we classify by sides, an equilateral triangle has 3 equal sides. An isosceles triangle has 2 equal sides. A scalene triangle has no equal sides. So for this first chunk, 1 through 4, we're classifying each triangle as equilateral, isosceles, or scalene. And then in the second one, you're classifying each triangle as acute, obtuse, right, or equiangular. So let's add that word up here. Equiangular, I'm gonna add it on the side. So we talked about equidistant, meaning that things were the same distance apart. Equiangular means that all the angles are equal. They're all the same, equal angles. So pause the video, try to label this first section based on their sides, second section based on their angles. All right, check your answers here. You should have equilateral, scalene, isosceles, isosceles. For 5 through 8, you should have acute, right, obtuse. The last one can be called either equiangular or acute. It fits both definitions. All of our angles are less than 90 degrees, and they're all the same. For the next section, you have to classify these triangles. And in order to do that, you need to draw yourself a picture. So we are told for number 9 that we have triangle ABC with segment AB congruent to segment BC. So saying that this is triangle ABC tells me that my vertices, the corners of my triangle, are labeled A, B, and C. So here's my triangle. So I'll have A, B up there, C over here. I'm told that AB is congruent to BC. So I'm going to indicate that on my picture. So the sides are congruent. So in this case, I have 2 congruent sides. That means my triangle is isosceles. All right, try 10 through 13. Draw your triangles, label that given information, decide what kind of triangle it is. Pause the video, check your answers when you're ready. All right, check your answers for these. Some things to be careful of. When you're drawing out the picture for number 10, they tell us that the measurement of angle E is 90 degrees. So angle E has to be my right angle here. In number 12, they tell us that none of our sides are equal to each other. So in my diagram, I make sure I mark them with different tick marks to show that none of these are the same. Okay, the last section asks you to determine whether a statement is always, sometimes, or never true. So for these, you're gonna have to do some thinking. See if you can draw yourself some examples or a counter example if you think something might never be true. Try them out. We'll discuss these in class together. But I'll put the answers up here just in case you're not joining us for our class discussion. But try them out on your own first. Pause the video before you check your answers. All right, here are my answers for those always, sometimes, or nevers. If you think that you found a counterexample for something I said is always true or something I said is never true, let me know. I am interested to hear your ideas. So it's the end of notes number 3. So practice number 3 is posted on, is it? Yeah, practice 3 is posted on Classroom, and learning check 3 is posted as well.